angle between the orbitals containing electron pairs around the central atom. See, these are the bonding electrons. They are having some orbitals. And the angle between the orbitals, in which we are having what? Bonding electrons. Okay. The angle between orbitals in which you are having bonding electrons is nothing but called bond angle, isn't it? Now it can be expressed in terms of degrees, isn't it? In terms of degrees and minutes, like that. Okay. Now here, if you observe what happened, water H2O is having what? 104 degrees, or otherwise 104.5 degrees actually. Okay. Now here also it depends upon several factors. Hybridization. Okay. So when it is sp hybridization 180 degrees, sp2 120 degrees, sp3 109 degrees, like that it will have. So everything we'll discuss in the next tomorrow class. We'll discuss that, and the bond angle, everything will come there actually. Next we'll see what bond enthalpy here. It is defined as amount of energy. How much amount of energy is required to break 1 mole of bonds in a molecule, isn't it? 1 mole of bonds, if you want to break, how much energy is required? That is called what? Bond enthalpy. But the condition is that the 2 atoms must be in the gaseous state, isn't it? The 2 atoms, whatever the molecule must be in terms of what? Gaseous state, like that. So for example, I have taken hydrogen. Okay. Hydrogen I have taken, like this I have taken hydrogen. How many I have taken? 1 mole of hydrogen molecules I have taken. 1 mole means actually 6 into 10 to the power of 23 molecules. So when you break this bond, okay, by supplying some energy, how many bonds you are breaking, beta? 1 mole bonds you are breaking. For this much amount of energy is required. 435.8 kilojoules is required. Now this will be the bond enthalpy of hydrogen. Now bond enthalpy of hydrogen, if you observe here, bond enthalpy of hydrogen. Shall I write like this? Bond enthalpy of hydrogen, I can write. This is called enthalpy. Delta H means what? Enthalpy. Be means what? Bond energy. So enthalpy of bond energy of hydrogen is nothing but called 435.8 kilojoules here. For example, you take oxygen here. How much it will be? 498. For example, if you take nitrogen, how much it will be? 946. As number of bonds, you see here in single bond you are having in hydrogen. In oxygen you are having double bond. In nitrogen you are having triple bond. As number of bonds are increasing between the atoms, what happened? Definitely the bond energy will increases. For example, if we take what happened, HCl. HCl. HCl is having what? 431 kilojoules of energy, isn't it? In this way, what happened? We can calculate. But here, what happened? When you get for this is what single molecules. That means atom one having only one bond, because between what happened only one. That means within pi bond also I'm saying. But when you consider what water molecule, polyatomic molecules like water, it will have what? Several bondings will be there here. Several type of bondings will be there. In this first one, second one, isn't it? 2 types of bonds are there here. First one, second one. In that case, what happened? Calculation little bit difficult for us, isn't it? Calculation little bit difficult for us. Why? Because if you observe here, I'm breaking like this. HOH. First of all, I'm breaking this bond. For breaking this bond, for 1 mole, how much energy I required here? 5 naught. The amount of energy required here, 5 naught. After that, when you break this one, what we get? H plus OH I will get here, right? Next, second bond I want to break here. OH bond I want to break. Now breaking this bond, I need only what happened? 427 joules. Why? Because the second is what? Very easy, no? Compared to this one, 502, 427 is easy. Why? Because water is stable molecule, where OH is unstable molecule. So breaking the stable is very difficult for us. Okay. So that is the reason what happened. Environment we have to consider. Environment. Okay. Here the environment is different. When you are breaking this one, the environment is different. When you're breaking this one, the environment is different. So in that case, what we have to take? So you have to take what? Average bond enthalpy. Now we get a doubt. If anybody asks you what is the bond length, OH bond length, okay? What is the bond energy? What is the bond energy of OH in water? If they ask, question is what? What is the bond energy of OH in water? Whether we have to take 502 or whether we have to take 427, we have to take an average value. You have to take average means 502 plus 427 by 2. The average bond enthalpy is what? 464.5 kilojoules actually. Understood here? So in that case, what happened? You take average bond enthalpy, isn't it? Average bond enthalpy. Now in examination, whether we have to have these values, no. Nobody asks what is the value, isn't it? They may give the values and they ask to calculate average. Okay, they will give the values, they ask calculate average value, but they don't ask singly what happened, what is the bond length of OH. Like that, nobody asks. Data you don't get as a questions. Never in even any subject what happened, data like what happened, this bond enthalpies, they don't ask in examinations. The thing is what? Bond order. Now what is bond order? See, actually what is bond order means very simple. I can say how many number of bonds present between the atoms. The number of bonds present between the atoms, isn't it called bond order? Okay. So generally what happened, I will take what happened something like this. Now if I take what happened, hydrogen, hydrogen. Now can you say what is the bond order for this one, beta?
So 1.
Only 1, because one bond is there between the two atoms, therefore bond order will be 1. For example, if I take like this, what is the bond order?
2.
For example, if I take N triple bond N,
3.
so maximum bond order will be 3 only. Maximum it will be 3 only. Lesser than or equal to 3 only. Okay. So bond order cannot be more than 3. Most of the case, 99%, most of the case, what happened? The bond order cannot increase more than 3, because when you have more than 3 bonds between the two atoms, what happened? It can't accommodate more bonds between the two atoms. Maximum we can accommodate 3 only. 4th one is impossible, isn't it? In general, actually. Okay. So this bond order separately we'll discuss, isn't it? In molecular orbital theory. In MOT theory, calculation of bond order we'll discuss separately. Okay. All molecules will differ, because that is an examination point of view. Bond order is very, very, very important. So that we'll discuss in the last chapter, last topic in this chapter, the last topic in this chapter. Actually. So next we'll see what this some type of exercise also we'll see bond order and bond length, everything we'll see. Now actually, we are just now we have seen what actually bond length, right? Bond angle, bond enthalpy, bond order, we are just completed, right? Bond length, bond angle, bond length, everything we are completed. These 4 actually. The resonance structures we'll discuss separately. And the polarity of bonds also we'll discuss separately tomorrow. That right? Bond length already I said no. This is the equilibrium distance, beta. I told you no equilibrium distance. This is the equilibrium distance between the center to the center, actually. Center to the center, isn't it? Equilibrium distance between the nuclei of the two bonded atoms. Internucleus distance, isn't it? Generally, they are measured by X-ray diffraction method. Just I am revising the things, actually, what we discussed now. Now, we have already seen this one. 154 picometer, isn't it? 150 picometer, everything we have seen this one, right? 154, 134, and what 120 picometer. Right. Next, if you observe what happened, hydrogen molecule bond length, if you observe 74, 144. No need to remember better. Nobody asks you why this is having what is the bond length of fluorine, what is the bond length of fluorine. Nobody they ask like that, isn't it? So no need to remember this. Just to show this one, how they are having like this. Next, how to calculate the radius beta? Half of the distance, isn't it? Half of the distance of bond length is called nothing but called radius, actually. In bond angle, already we discussed this one. Okay, angle between the orbitals, isn't it? Just now we completed this one. The angle between the orbitals containing what? Bonding electron pairs. These are the bonding electron pairs. How is the angle between these two bonds is nothing but called bond angle. Okay. Now, what is the use of this one? We can easily predict the shape of the molecule. How let me see in the valence electron pair repulsions theories. These are some questions. Okay. Right. Next, bond. Can you give the question answer for this one? Which
Sir,
distance?
equilibrium.
Equilibrium distance between the nuclei of bonded atoms. The bond angle in water you observe here?
Option D.
Sir, D 104.5.
104.5. Let me see the bond enthalpy also again one more time. The amount of energy is because definitions they may ask in examination. Amount of energy required to break how many moles? 1 mole of bond size. So we have taken hydrogen as example here, 435.5. In case of polyatomic, we get something complicated this. So in that case, we'll take what? Average value, right? We'll take what actually? Average value we'll take here. So for one, we got 502. For second one, we got how much? 427. So average we are getting how much? 464 actually. So bond order, the number of bonds between the two atoms. The number of bonds between the two atoms. Here, hydrogen 1, oxygen 2, nitrogen will be 3 like this. For isoelectronic molecules and have identical bond orders. For example, you don't know F2 minus 2, correct or not? You don't know F2 minus 2. When you increase bond order, bonds also will increase. For example, if you take like this, one bond. For example, if you take two bonds. For example, if you take three bonds. As number of bonds are increasing, what happened? Bond order is increased. When bond order is increased, what happened? The amount of energy is required to break this bond also will be more. How much energy you are requiring? Only less energy because one bond you are breaking. But here three bonds you need to break. So that is the reason here we need more bond enthalpy. Here bond enthalpy is what more here. Why? Because bond order is what more. When bond order is more, that means number of bonds are more, bond energy also will be more actually. Okay. After that bond order, bond length. When you get more bonds, what happened? It come near, no? See, for example, how much bond length it is having? 154 picometer, 134 picometer, and 120 picometer. So when you have more bonds, what is happening by time? They're coming near. Therefore, bond length, what happened here? Decreases when you get more bond order. So this is important for you. Remember this one. What is the relationship between bond order and bond length actually? Okay. This will get in the next balance shell you will get definitely. So no need to bother about this one, right? So ये आपको बाद में मिलेगा tomorrow. So remaining topic is there. Chemical bonding is the resonance structures are there. Resonance structures we'll discuss tomorrow. Okay, tomorrow I will take the class. So this is about today class. So should I have class 12th? I have class. So in 12th actually we need to finish syllabus. That is the reason.